Hi, I'm Kevin, and I'm here to teach your code to describe its own architecture. What do you think of this quote? Documentation is the castor oil of programming. Managers think it's good for programmers, and programmers hate it. Well, it's true that we prefer to code. That's why we're developers. But what if we can transform a documentation problem into a coding problem? I'm a developer, so when someone asks me for documentation, what I want to do is build a program that makes documentation. Making code that makes documentation doesn't feel like drinking castor oil. It feels like making robots, which is what we all love to do, right? A bit more about me. You can think of me as an inventor, using software as a medium. I started my career with C++ and Java in 1995, building early interactive web apps. I went on to start my first company in 2005 and joined the Ruby on Rails community in 2008. In 2012, I founded a DevOps cybersecurity company called Conjur, which was acquired by a larger company in 2017. As we tried to integrate our cloud-first Rails app with their Windows Data Center product, we were really hampered by the lack of good architecture and code design documentation. It was pretty disappointing and confusing. We had good documentation of Conjur. It has a web service API, server configuration and setup, high availability, and it was all documented, extensive test cases. So why was there still so much confusion among developers about what it did and how it worked? I think it's because we write documentation for a different audience, which is users. So even when we write good docs, and even when they're up to date, we don't help ourselves too much. There's a lot that we would like to be able to learn and discover from docs and diagrams, but we can't because they were written with someone else's needs in mind. So who's making these architecture and code design decisions? Well, we are. In 2021, freedom to make decisions about code design belongs to developers. Architecture is not something that's dictated by architects generally anymore. To demonstrate this, here are some results from a survey that we're conducting called the State of Software Architecture Quality. One of the questions we ask is, who's primarily responsible for enforcing software architecture quality? And the answer is 68% of the time, developers, and only 18% architects. So because we, developers, own the decisions, we also have responsibility to communicate and explain those decisions to other developers. And what kind of doc do we need? As we work, we all play two roles. When we work in code that we wrote ourselves, we play the expert role. We know how it works, and we're the go-to source for questions. But when we work in code that we don't know, it's different. We play a newcomer role because it's unfamiliar. Documentation serves users, both internal and external, but usually not the people who work on the code. We need a new kind of documentation which experts create with code as they work, so that it's there when the newcomers need it. In our survey, we also asked, would you like to have up-to-date diagrams and visualizations of code structure? And 84% said yes. Then we asked, do you use existing code architecture and visualization tools, and would you like to keep using the tools you're using? And 81% said no. So the data shows that we want up-to-date diagrams and visualizations that are useful to us in our work. And there are tools that seem like they might provide this, but they're not meeting our need. In a perfect world, what would we have available to us as we work? Docs and diagrams that are up to date. They need to match the code exactly. They should be interactive so that we can use docs like an app. Static pictures don't scale. These docs would be contextual so that we can get exactly what's relevant to our task. Because even when information's accurate, it's not useful if there's an overwhelming amount of it. And it should be as close to the code as possible, because the code is where we work, and the code is our source of truth. And we need to be able to move seamlessly back and forth between the code and our documentation app. So, with the remainder of this talk, I'm going to demonstrate a few tools that I think can take us in the right direction. These are tools that automatically generate documentation and visualizations of architecture and code design. The framework to keep in mind is model view controller architecture, because we all know models, views, controllers, and how they work together. So I've chosen tools that auto-document the following things. First, end-to-end flows. This is how we get the right context. For example, figuring out how a given web request uses particular tables, or finding important functions performed by code such as authentication, authorization, email, background jobs in a particular service. In essence, the named actions performed by the code. Second, web services. These are the commands that are sent to the app. And third, the data model. Interacting with the data store is what the app really does from the standpoint of the user or the business. The operations that the code performs on the data store are much more important than the code itself. I'll start with AppMap, which provides both high-level and low-level views of end-to-end code and data flows. If you want to follow along in the code or look it up later, I've created a fork of the Rails sample app 6th edition. Within that fork is a branch called Eager Loading. So what's AppMap? AppMap is an OSS project that I created and I'm working on actively. AppMaps help you navigate and improve your code by showing you how it really behaves feature by feature as you work. It does this by recording code behavior into AppMap files during program execution. Then you can visualize the AppMaps or analyze them using built-in analysis or your own custom code. For Ruby, you install AppMap as a gem, then configure which source files and dependency gems you want to record. Then you record AppMap files by running code, such as test cases. This is different than static analysis, which only looks at your files on disk. AppMap records your code while it's running, so it knows exactly what happened at every point and how all the code, services, and data stores fit together. To create AppMaps, you install and configure the AppMap gem. Then run any code, such as a test case, with AppMap equals true. Let's take a live tour using the Rails sample app. I'll start by logging in. The function of this app is to make little Twitter-style microposts. I've installed AppMap in the gem file. And I've configured the Rails source directories and some selected dependency gems in appmap.yml. Now I can run any test with AppMap equals true to generate AppMaps. I'll run a test, an integration test called users sign up test. In this project, I have AppMaps of every mini-test test case. Each AppMap is a data file that contains a wealth of information about what happened in the code while a test case ran. If I open any AppMap, I get a visual depiction of the code execution that's interactive. Opening any app map shows the Dependency Map View. This is your big picture view. You can see all the components that are relevant to what you're working on and how they're connected. It shows HTTP server requests, code, and SQL. You can search and navigate through web services, code, libraries, and SQL, all in the context of a particular feature. Code is depicted as packages, which can be packages in this project or third-party gems. And from any node, you can drill down into the trace view. The trace view shows code execution in detail as a tree. At the base of the tree are HTTP server requests. The leaves of the tree are functions and queries. Each function call and query has full details: parameter values, return values, exceptions, all recorded from program execution. You can click View Source on any class or function to open the source code in the IDE. Key functions are labeled so that you can quickly find important functionality such as authentication and cookies. So AppMap combines low-level and high-level information. And links it all together. And it shows you how the code handles requests, how key functions such as authentication are performed, and how incoming requests affect the database and external services like S3 and other web and cloud services. AppMap provides the high-level navigation of the code interactively like a Google map. You can write analysis code on the AppMap data, which we'll see in a later section. And from AppMaps, you can dive into source code, debuggers, etc. for further details. Next up, web services using Swagger, also known as OpenAPI. There's a branch called Swagger within the Land of Apps fork of the Rails sample app, 6th edition, same repo that I used for AppMap. You can check out the branch for all the code that I'm going to show in this section. Swagger takes YAML or JSON files and generates a web page, which is an interactive catalog of your web services. The catalog contains routes, methods, status codes, parameters, request body, authentication methods, and more. The Swagger spec is extensive and detailed. Swagger is oriented towards documenting published APIs because it's pretty laborious to write and maintain the files. With auto documentation, it can be worthwhile to document internal APIs too. Writing Swagger files is frankly pretty tough, and there's a challenge of keeping it accurate and up to date. So we can generate Swagger files. So can we generate Swagger files instead of writing them? I'm going to show two ways of doing that, starting with a gem called RSwag. In RSwag, you write tests in a dialect of RSpec, and it generates Swagger JSON or YAML. RSwag is a gem, and it provides a rake task to generate the Swagger files from the data you create in RSpec. Let's take a look at how it works. In the gem file, we'll find the RSwag gem. In routes RB, you'll find two RSwag engines, UI and API. Because RSwag actually serves the Swagger catalog directly from inside your app. This is very handy because it means that the Swagger UI and your app share the same session. So you can swap back and forth between the Swagger UI and your app, interacting with both at the same time. So I'll log into the UI. Make a micro post. Okay, and then let's see the Swagger UI. You can see two functions here in Swagger. The first one is a route to get microposts, and this is a JSON API style function. The second one is a function to create a micropost. Let's try this function right here in the UI. This is one of the features of the Swagger catalog. So I can execute this method, and I get back a JSON list of my microposts. And since I'm logged in, and both of these tools are sharing the same session, I'm authenticated and I can interact directly with my data. Let's take a look at where that came from. Here's my RSwag tests, micropost controller spec. So I'm not using standard RSpec. I'm using these methods like path, get, and response. These essentially mirror Swagger very closely. Here's the Swagger, paths, route, get, response, very similar. So if I want to add another route to my Swagger, I can add a new test. I can run that test if I want to. And then I run the rake rswag specs swaggerize command, which will run over my rswag and update the swagger.yaml. So now you can see the logout route here at the bottom. And if I go back to my Swagger UI, refresh, now I have the logout route. So if I do that, as you might expect, I'm logged out of the app. So from a developer standpoint, updated Swagger should be committed by us when we make a web services change, similar to schema migrations or structure.sql. And then it can be diffed and reviewed in a pull request using standard source diff and other procedures. So this provides a powerful way to track and review changes to application web services. Let's talk about some pluses and minuses with RSwag. On the plus side, the Swagger is auto-generated from test cases, so it's accurate. RSwag also ensures that the Swagger file is valid because it does assertion checks when it actually runs the tests. You run those tests as RSpecs, and they are validated, and that gives you assurance that your Swagger is correct. And RSwag is also very customizable. Most, if not all, the features in OpenAPI are also features of RSwag. So if you know that format really well, you can put a lot of detailed information into your Swagger files. On the minus side, you may have a lot of specs already that aren't written using RSwag flavored RSpec, And to use RSwag, you have to port or rewrite those over in the RSwag flavor. And you also need to learn a lot about the OpenAPI format, because essentially the RSwag format is the OpenAPI format. So you don't get a lot for free there. You really have to know what to put in. So I'm also going to talk about another option for Swagger, which is called AppMap Swagger. And this is brand new code that I just wrote for this presentation. So if you go try it, and I hope you do, just remember that it's young code. And what it does is it generates Swagger from AppMap files, which are pre-recorded from test cases. So in order to generate Swagger with AppMap Swagger, you install an npm package, a node package, and then add an AppMap Swagger rake task, and you can see that in the sample app for an example on the Swagger branch. And you can generate Swagger using rake AppMap Swagger. Let's take a look at a demo of that. So I've shut down the server. I'm going to go over to the configuration RSwag UI. So I'm switching my source of Swagger authority, if you will, from this directory, Swagger RSpec, over to this directory, Swagger AppMap. And let's try rake AppMap Swagger. What this is going to do is it's going to crawl over all these AppMap files, the same as what you saw before. And each of these files contains data from a particular test case, including examples of web service calls. So AppMap Swagger finds all the web service calls that are in the AppMap files, combines it all together, and converts that information over into Swagger doc. And it looks like this. Similar to what we saw from RSwag, except more of it. So this was all completely discovered from within my app maps. And if I go refresh the UI, I'll see this very extensive list of routes. And all this came from test cases that I already had, because the Rails sample app, as you can see here, has a good amount of tests. So AppMap Swagger also makes it easy to add a little bit of parameter type information. So for example, I can go in here, and these fields are already created for me, and I'll put in my username and my password, execute that, and then when I go over here to the app, I'm logged in. Similar to what we saw with RSwag. So pluses and minuses of AppMap Swagger. On the plus side, it uses your existing test cases, request functional controller and integration tests. Anything that hits a controller or hits a web service route will be discovered and incorporated into Swagger. Since it's generated, it ensures that the Swagger file is valid, and it matches whatever your code does, because it is literally made from your code. So it's accurate as far as the code behavior. And you can get more complete API coverage faster because it leverages the test cases that you've got. You also don't need to learn very much about the OpenAPI format. I didn't actually show you any OpenAPI there that was handwritten by me. There was a little bit there to do the login format. But for the most part, you just get to use the OpenAPI tools instead of having to learn all the guts of how they work, which I like. On the minus side, it's less customizable than RSwag or writing your own Swagger, because it's generated from using a code generator. So there's fewer options for configuration there. So in summary, on Swagger, you can see your whole web services catalog and interact actively with your API. Swagger also has some other functions like generating client code. You can debug your web services in a very granular way. You can observe your test coverage visually. You can see what's covered and what isn't reflected back to you in Swagger. And you can diff your web services changes by committing your Swagger YAML and then going through the standard review process. Final segment will be on entity relationship diagrams. Also a branch of the sample app 6th edition fork. An entity relationship diagram, if you don't know, shows the tables, columns, and relations in a relational database schema. And of course, we want to auto-generate the ERD for a specific version of our code directly from the database. So I'll show a gem called RailsERD that does this. RailsERD works by gathering database metadata through active record. It uses active record, so it's database independent. Once it analyzes the schema, it generates a dot file, which can be processed by GraphViz into a PDF. And all of this can be bundled up into a rake task, which we can use to update the ERD when we modify the schema. So in the project that I'll demonstrate, the ERD rake task is configured to run automatically after DB migrate. So whenever the schema changes, the schema diagram changes too. To use ERD, you RailsERD, install GraphViz and the RailsERD gem, and then run rake DB diagram. So let's take a look at it. Here's my sample project. RailsERD installed here. So bundle exec rake diagram. Running this rake task updates this file called entity relations.pdf. And in that file, you can see a detailed diagram of the schema. This is useful for analyzing the data model of an app and identifying features such as nullable and not nullable columns, column types, primary keys, foreign keys, and the different types of relationships. One to many, many to one, and many to many, one to one, etc. I can also get other insights from looking at the schema, such as security. I can see that the password, remember token, and reset token are all stored as a one-way digest, so that if an attacker obtained access to this database, they would not obtain these secrets. So, ERD, you get complete details of your database schema. We've just explored the fully automated creation of 3 types of code design docs. AppMap, covering end-to-end code and data flows, Swagger, covering web services APIs, and ERD, describing the database schema in detail. And as I mentioned, all this code is available in our fork of the Rails sample app. So here are those URLs again. There will be a dedicated Q&A session for this talk in Discord. The channel name matches the name of the talk, from 4:10 p.m. to 5:10 p.m. Eastern Daylight Time on Wednesday, April 14th. Thank you for your time, and I hope that I'll get to meet you in the Discord room.